Alright, so for problem number 2, we're going to need to state the intervals of convergence for a few series. So first, with problem A, we have the sum from n equals 1 to infinity of 3x minus 2 to the n power all over n times 3 to the n power. Okay, so for these types of problems, what you need to figure out is what values of x would make this a convergent series and which values of x would make this a divergent series. And then the interval of convergence is all the values of x that make it a convergent series. Typically, for these problems, you're going to have exponential terms, which should let you know that using the ratio test is usually a good idea. So, by the ratio test, we're going to have 3x minus 2 to the n plus 1 all over n plus 1, 3 to the n plus 1, times the reciprocal of our original, n3 to the n, 3x minus 2 to the n. So when you're doing these interval of convergence problems for x, it's very important that you do include the absolute value, because x could be anything, not like n's, which we know are positive anyway. When you have the x's, you really got to make sure you include those. And of course, we're doing the limit as n goes to infinity. Alright, so let's see what cancels out. 3 to the n leaves a 3 on the bottom. This leaves a copy of 3x minus 2 on the top. We have n and n plus 1 as well. Those don't cancel out, but we'll see in a second they really kind of do. Let's rewrite what we have left. So we have 3x minus 2, and you can put just that part in absolute value because that's the only part left that could be negative. Divided by the 3 we had left from here. And I'll write the n and n plus 1 in a separate fraction. And we're taking the limit as n goes to infinity. So what you can see here is that limit as n goes to infinity only applies to this part in the first place because we don't have any n's here. And since these are both degree 1, we just use the coefficients. That tells you that this is just 1. So eventually we just get absolute value of 3x minus 2 divided by 3. And we know because we're using the ratio test and we're trying to find where it converges, we know this has to be less than 1. So now we just have to solve for x. So we multiply by 3. So the absolute value of 3x minus 2 has to be less than 3. That means that 3x minus 2 has to be between 3 and negative 3. If its absolute value has to be less than 3. And we can just solve for x here by doing regular algebra stuff. Add 2 to both sides and divide both sides by 3. So we get that our interval of convergence goes from negative 1/3 to 5/3. But here's what you got to be careful about. Just because the ratio test says that this has to be less than 1 to guarantee convergence, and I mean strictly less than, and that these are not or equal to signs. Remember that if the ratio test ends up being exactly 1, that doesn't mean divergent, that just means inconclusive. So if x actually is negative 1/3 or 5/3, the ratio test wouldn't tell us anything. We still have to check those. So what I'm getting at is you can't just say these are parentheses, end of the problem, because these were strict inequalities. It doesn't work that way. We actually need to just figure out what happens when you plug in the boundary points. Okay, so let's start with the positive one, 5/3. If we plugged in 5/3 for x, we would get 5/3 times 3, which is 5. 5 minus 2 gives you 3. We would get, for x equals 5/3, our series would become 3 to the n over n 3 to the n. In other words, just 1 to the n. Or 1 over n, sorry. And you know that the sum of 1 over n, that's the p series with p equals 1, harmonic, diverges. So we know that 5/3 actually does make this diverge, so that's not in the interval of convergence. We can for sure put a parenthesis there. Now we have to check the other. What if x is negative 1/3? Negative 1/3 times 3 gives us negative 1. Negative 1 minus 2 gives us negative 3 to the n over n 3 to the n. In other words, negative 1 to the n over n. So that's the harmonic series, p series with p equals 1 also, except now it's alternating. For an alternating series, we have to use the alternating series test. Is the limit as n goes to infinity of 1 over n equals 0? Yes, because as n goes to infinity, this fraction gets small. Is the sequence decreasing? 1 over n, as you keep going further and further with n, 1, 2, 3, the denominator just gets bigger and bigger, meaning the whole fraction gets smaller and smaller every term. It's clearly decreasing. So, that tells us that while 1 over n does not converge, the alternating version of 1 over n does converge, meaning that x equals negative 1/3 is in our interval of convergence because that number for x makes it converge. So our interval of convergence is from negative 1/3 to 5/3, including negative 1/3, but not including 5/3.